Welcome. Today we're going to continue practicing solving equations with the distributive property. Right now we're going to look at 2 word problems, and then we'll practice a few different strategies that you can use to solve equations with the distributive property. So let's look here at question 3. This says each of the graphic novels in Chen's collection increased the value by $3.50 in the last few years. If each graphic novel has the same value, what was the original value of one graphic novel? Now, if we're looking at this, the question that is being asked is what was the original value of one graphic novel? Most of the time, when we are solving equations, whatever the question is asking us for is what our variable will represent. So in this case, when we define our variable, I'm choosing to use x, we will say that x represents the original value of one graphic novel. Now, over here we can see that he has 10 graphic novels, and the current total value is $75. So that means when we're building our equation, we know the total value is $75. Now, the way that we can represent one value of a graphic novel is it's the original value plus, because it has increased, plus $3.50. So we can say x plus $3.50. This is the cost of one value, or one graphic novel. Now, because he has 10 graphic novels, we can multiply this amount by 10. So each graphic novel has increased by $3.50. There are 10 graphic novels, so we multiply that together, and that will give us the current value, which is $75. Now we can go ahead and solve this equation. So I'm going to go ahead and distribute out the 10. So we'll have 10 times the first term, which is x, plus 10 times the second term, which is $3.50, equals 75. Well, 10 times x is 10x. 10 times $3.50 will be 35, and this still equals 75. At this point, I can now go ahead and start getting rid of numbers to get x by itself. Starting with this 35, I can cancel that out by subtracting both sides by 35. Now down here there isn't quite enough room, so I'm just going to draw an arrow over here to the side so I can continue solving this. Plus 35 minus 35, those will cancel out, so we're just left with 10x. We'll have our equal sign, and on the right side, 75 minus 35, when we subtract that, we'll end up with 40. So now we have 10x equals 40. Well, 10 and x are being multiplied together, so we can undo that multiplication by dividing. So we can divide both sides by 10. Times 10 divided by 10 will cancel out. So we are left with x equals, on the right side, we have 40 divided by 10. That will leave us with 4. So we can say the original price of one graphic novel is $4. For the next word problem, it says a grocer bought some bags of flour from a wholesaler. After taking 2 bags home, he sells the remaining bags for $7 each, for a total of $126. How many bags of flour did the grocer get from the wholesaler? Well, the question that I'm being asked here is how many bags did the grocer get from the wholesaler? So that's exactly what we will define our variable as. X equals the number of bags from the wholesaler. Now, if we're going through this, I know that the total amount of money the grocer sold the bags for was $126, so I know this will end up equaling $126. Now, the grocer bought some amount of bags. Maybe he bought 10 bags or 100 bags or 3 million bags. We don't know. He took 2 of the bags home and sold the rest of the bags. So if he's taking some of the bags from the wholesaler storing them at home and selling the remaining amounts, that means we would subtract. So it's the total amount that he bought from the wholesaler minus the 2 bags that he's keeping at home. So we can say X minus 2. This represents how many bags remain. Now, he sells each of those for $7, so we can go ahead and multiply the number of bags that remain times the cost of $7, and that'll give us the total money that he earned from that. Well, now that we have this equation, we can go ahead and solve. So I'm going to distribute the 7 out, so 7 times X minus 7 times 2, oops, that was not necessary, equals 126. Well, 7 times X is 7X, minus 7 times 2 is 14. That equals 126. At this point, there's no grouping, so I can go ahead and start removing whatever numbers I want. I want to remove this negative 14. I can do that by adding 14 to both sides of the equation. Minus 14 and positive 14 will cancel out. So over here, we will still have 7x on the left side of the equation. On the right side of the equation, 126 plus 14 will give us 140. Now, because the 7 and the x are being multiplied together, we can cancel that out by dividing both sides by 7. So we will be left with x equals 20. So we can write our final answer as a sentence. It's answering this question: how many bags of flour did the grocer get from the wholesaler? We can say he got 20 bags from the wholesaler. On the back, we will be looking at 3 different ways that we can solve equations. The first method is just like what I modeled here, where we will distribute out whatever is in front of the parentheses to each of the terms inside the parentheses. What makes this slightly trickier is that these have fractions in front of the parentheses. So we have a 3/4 for this problem, and down here we have a 2/3. So our first method is just distributing. Well, if I'm writing out that distribution step, that's where I show I'm taking whatever is out front and I'm multiplying that to each of the terms inside the parentheses. So we have 3/4 times x plus 3/4 times 8. And then we still have that this equals 18. All right, now I can go ahead and do this multiplication. 3/4 times x is 3/4 x plus 3/4 times 8. I'm going to put this as 8 over 1. Well, I can actually cancel some things out. 4 and 8, we can divide both of those by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So now when we multiply across, 3 times 2 is 6 over 1 times 1 is 1. So we have 3/4 x plus 6 equals 18. At this stage, there's no grouping, there's no parentheses, so I can finally remove the numbers as I want. I want to remove the 6 first, so I can cancel out adding 6 by subtracting 6 from both sides. So we'll have 3/4 x equals 12. Now 3/4 and x are being multiplied together. However, we could divide both sides by 3/4, but that's pretty difficult to do. So instead of dividing both sides by a fraction, we are going to multiply both sides by the reciprocal. So the reciprocal is when you take a fraction and you flip the numerator and the denominator. So the reciprocal of 3 over 4 will be 4 over 3. And I'm going to multiply that amount to both sides of the equation. Now that we've multiplied both sides by 4 over 3, we can go ahead and cancel things out. 4 in the numerator and 4 in the denominator will cancel out. 3 in the numerator, 3 in the denominator will cancel out. So on the left side, we are left just with x. On the right side, 12 and 3, you can divide both of those by 3. 3 divided by 3 gives us 1. 12 divided by 3 gives us 4. So when we multiply across, 4 times 4 is 16. So we will get that x equals 16. Down here, for our next problem. If we have 2/3 out front, we can go ahead and distribute that out. So we will have 2/3 times 5x minus 2/3 times 6, which will equal 26. And next we do that multiplication. Well, 2/3 times 5x, that doesn't work out quite so nicely, so we multiply across. 2 times 5x is 10x over 3 times 1, which is 3. Next up, 2/3 times 6 over 1. Well, 6 and 3 are both divisible by 3, so 3 divided by 3 is 1, 6 divided by 3 is 2. So now when we multiply across, 2 times 2 is 4, and since this is subtracting, this will be negative 4, and this will equal 26. At this stage, there's no grouping, there's no parentheses, so we can go ahead and rearrange the terms however we want, which for us, this is arranged in the order we want, so we can now go ahead and remove the numbers as we want. So 10/3 x minus 4, we want to remove the constant first, which will be this 4. We can remove that by adding 4 to both sides. So minus 4 and plus 4 will cancel out. So we are left with 10x over 3 equals 30. Now at this point, we can go ahead and either both divide by 10 and multiply by 3 to get rid of these two numbers, or this is really just 10/3 times x. So just as before, you can, rather than dividing by 10/3, since it's difficult to divide by a fraction, we can instead multiply both sides by the reciprocal. So the reciprocal of 10 over 3 would be 3 over 10. So if we multiply both sides of the equation by 3 over 10, now 3 in the numerator, 3 in the denominator cancels out. 10 in the numerator and 10 in the denominator will cancel out. Over here, this will be 30 over 1. Well, 30 and 10 are both divisible by 10, so 30 divided by 10 is 3. 10 divided by 10 is 1. So now we're left with just x on the left side of the equation, and on the right side of the equation we have 9. So we get that x equals 9. So this is one strategy that you can choose to use when solving an equation that has distribution in it. You can choose to distribute that out. Now, if you do not like distributing, you really do not enjoy it, good news is there's another option. You can choose to cancel the distribution. The way that we can cancel distribution is by getting rid of that. So in this case, we can see we are supposed to multiply 3 over 4 to x and multiply 3 over 4 to 8. Well, instead of doing that multiplication work, we could instead cancel that out. So rather than dividing both sides by the fraction 3/4, again, dividing by a fraction is difficult, we will instead multiply by the reciprocal. So I'll multiply the left side by the reciprocal of 3/4. So when we flip that, we'll have 4/3. And on the right side, I'll multiply that as well by 4/3. So now, when we multiply 4 in the numerator, 4 in the denominator cancels, 3 in the numerator, 3 in the denominator cancels. So I am left with whatever was inside the parentheses originally, so x plus 8, my equal sign. And over here, 18, 4, 1, and 3, well, before I multiply across, 18 and 3, I can simplify those. I can divide them both by 3, so we'll get 6 and 1. So now when we multiply across, 6 times 4 is 24, over 1 times 1 is 1. At this point, to finish getting x by itself, we have to get rid of this plus 8. I can cancel that out by subtracting 8 from both sides of the equation. So we will have x equals 16. And sure enough, we got the same answer as what we got the first time. For this next equation, again, same problem as what we did just to the left of it. Again, if we want to cancel out the distribution, we can do that by, instead of multiplying this 2/3 out to everything in the parentheses, we can cancel that. So instead of dividing both sides by 2/3, we can multiply by the reciprocal. So the reciprocal of 2 over 3 will be 3 over 2. So now when we go through this, 3 in the numerator, 3 in the denominator will cancel out. 2 in the numerator, 2 in the denominator will cancel out. And over here on the right side, 26 times 3 over 2. Well, 26 and 2, you can divide both of those by 2. 26 divided by 2 is 13. 2 divided by 2 is 1. So now we're just left with what we had inside the parentheses, 5x minus 6 equals 13 times 3 over 1 times 1 will be 39. There's no parentheses trapping these terms together, so we can go ahead and start removing the numbers. So first we'll want to get rid of the constant, negative 6. We can do that by adding 6 to both sides. So we're left with 5x. And on the right side, 39 plus 6 will give us 45. At this point, 5 and x are being multiplied together, so we can undo that multiplication by dividing both sides by 5. 5 divided by 5 cancels out. So we're left with x equals 9, because 45 divided by 5 is 9. And that matches what we got before. The last option that you can sometimes use when solving equations where you distribute with fractions is to avoid dealing with fractions altogether. If you really don't like dealing with fractions, you can convert the fractions to decimals and then distribute them. So for us, 3/4 or 3 over 4, that is going to be the same thing as 0.75. So I'm going to rewrite this problem where instead of the fraction 3/4, I'm using the decimal version instead, which is 0.75. So I will have 0.75 times x plus 8 equals 18. Well, I'll go ahead and distribute that out. So I'll have my 0.75 times x plus 0.75 times 8, and that will equal 18. Now when we multiply this out, we'll have 0.75x plus 0.75 times 8 will give us 6, and that will equal 18. At this stage, we can go ahead and subtract 6 from both sides of the equation to get rid of our constant. So we're left with 0.75x equals 12. And 0.75 is being multiplied to x, so we can divide by 0.75 on both sides to cancel that out. And if you check on a calculator or do the work by hand, sure enough, we'll end up still getting that x equals 16. For this problem here, 2/3 parentheses 5x minus 6 equals 26. If we change 2/3, if we convert that into a fraction, well, 2/3 is going to be the same thing as 0.6666666, and it keeps going and going and going. This is a problem for us. We could try to represent this as 0.6 with a repeating bar on top of it, but we cannot do any math calculations with a decimal that repeats forever. So this actually is not possible for us. So you can only use the strategy of converting to decimals if the decimal ends up being a decimal that terminates or ends. If it goes on forever, you cannot use this strategy. So here, we cannot do math with a decimal that goes on forever. In this case, our only option is to keep in fraction form. So when it comes to solving equations where you are distributing and there is a fraction involved, I recommend mostly sticking with distributing it as a fraction or canceling out the distribution by multiplying both sides by the reciprocal. Because you cannot consistently, for every problem, convert the fractions into a decimal and then solve, I really do not recommend using this third method unless you really like working with decimals and you're really comfortable recognizing when you can and cannot use this method. Now for these 4 problems down here, these are questions just like what we saw up at the top. You will get to choose which strategy you want to use to solve each of these equations. Now, keep in mind, some of these equations, you might not be able to use this last option where you convert from fractions to decimals. So if you wanted to try to convert from fractions to decimals, for this first one, 1/4, well, if we think about this, 1/4, that will be the same thing as 0.25. This terminates, so you could use the third option if you wanted to. For question 2, 1/3, well, 1/3, this is going to be the same thing as 0.33333 repeating forever. Or we could write this as 0.3 with a repeating bar on top. Because this repeats forever, we cannot use this strategy. We have to keep it as the fraction form. For question 3, -2/5. -2/5, this will be the same thing as -0.4. This terminates, this stops. So you could choose to use any of the three options. For this last problem here, 5/6, this, when we convert it into a decimal, will end up being 0.83333 for forever. So this is the same thing as 0.83, where only the 3 is under the repeating bar. Because this decimal goes on forever, we cannot use this method. So for questions 2 and 4, you have to use either distributing in fraction form or canceling out the distribution in fraction form. For problems 1 and 3, you can choose any of the three strategies you want to solve those problems. Now, I'll go ahead and give you the answers. That way you know for sure if you solved them correctly. For question 1, you should end up getting that A equals -3. For question 2, we should get that A equals 25/3. Or if you want to convert that into a mixed number, that will be 8 1/3. Either form is fine. For question 3, you should end up getting that X equals -5. And lastly, for question 4, you should get that X equals 1/5.